RS ಕನ್ಫಿಗರೇಷನ್. ಮಿತ್ರರೇ, ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಹಾಗೂ ಕಾಂಪಿಟೇಟಿವ್ ಲೆವೆಲ್ ಎಕ್ಸಾಮ್ JEE ನೀಟ್ನಲ್ಲಿಯ ಒಂದು ಅತಿಶಯ ಕಠಿಣವಾದ ಪ್ರಶ್ನೆ ಅಂದರೆ RS ಕನ್ಫಿಗರೇಷನ್ ಡಿಸೈಡ್ ಮಾಡೋದು. ಅನೇಕ ಸಲ ಬ್ರಿಲಿಯಂಟ್ ಸ್ಟೂಡೆಂಟ್ಸ್ಗಳು ಕೂಡ RS ಕನ್ಫಿಗರೇಷನ್ ಡಿಸೈಡ್ ಮಾಡೋದ್ರಲ್ಲೇ ತಪ್ಪು ಮಾಡಿಬಿಡ್ತಾರೆ. ನಾನು ನಿಮಗೆ ಜಗತ್ತಿನ ಅದ್ಭುತವಾದ 4 ಕೋಡ್ ಟೆಕ್ನಿಕನ್ನು ನಾನು ನಿಮಗೆ ತಿಳಿಸ್ಕೊಡ್ತೇನೆ. ನೀವು ಯಾವುದೇ ಸ್ಟ್ರಕ್ಚರ್ಗೂ RS ಕನ್ಫಿಗರೇಷನ್ ಸಲೀಸಾಗಿ ಡಿಸೈಡ್ ಮಾಡಬಹುದು. RS ಕನ್ಫಿಗರೇಷನ್ ಅಂದರೇನು? R ಹಾಗೂ S ಇವು ಎರಡು ಲ್ಯಾಟಿನ್ ಶಬ್ದಗಳು. R ಅಂದರೆ ರೆಕ್ಟಸ್, S ಅಂದರೆ ಸಿನಿಸ್ಟರ್. ರೆಕ್ಟಸ್ನ ಅರ್ಥ ಕ್ಲಾಕ್ವೈಸ್ ಡಿರೆಕ್ಷನ್ ಹಾಗೂ ಸಿನಿಸ್ಟರ್ನ ಅರ್ಥ ಆಗುತ್ತೆ ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ಡಿರೆಕ್ಷನ್. RS ಕನ್ಫಿಗರೇಷನ್ನಿಂದ ನಮಗೆ ಏನು ಮಾಹಿತಿ ಸಿಗುತ್ತೆ? RS ಕನ್ಫಿಗರೇಷನ್ನಿಂದ ನಮಗೆ ಅಬ್ಸಲ್ಯೂಟ್ ಕನ್ಫಿಗರೇಷನ್ ಆಫ್ ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆಟಮ್. RS ಕನ್ಫಿಗರೇಷನ್ನಿಂದ ನಮಗೆ ಅಬ್ಸಲ್ಯೂಟ್ ಕನ್ಫಿಗರೇಷನ್ ಆಫ್ ಕೈರಲ್ ಕಾರ್ಬನ್ ಆಟಮ್, ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಬಗ್ಗೆ ಸವಿಸ್ತರವಾದ ಮಾಹಿತಿ ಸಿಗುತ್ತೆ. ಅಬ್ಸಲ್ಯೂಟ್ ಕನ್ಫಿಗರೇಷನ್ ಆಫ್ ಕೈರಲ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂದ್ರೇನು? ಅಬ್ಸಲ್ಯೂಟ್ ಕನ್ಫಿಗರೇಷನ್ ಆಫ್ ಕೈರಲ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಮೀನ್ಸ್ ದ atoms or group of atoms attached to the chiral carbon atom according to priority order they are in clockwise direction, or according to priority order they are in anti-clockwise direction. This information is obtained from RS ಕನ್ಫಿಗರೇಷನ್. ಮಿತ್ರರೇ, ಯಾವಾಗ ಮಾಲಿಕ್ಯೂಲ್ ಫಿಶರ್ ಪ್ರೊಜೆಕ್ಷನ್ ಫಾರ್ಮ್ನಲ್ಲಿ ಕೊಟ್ಟಿರುತ್ತಾರೋ ಆವಾಗ RS ಕನ್ಫಿಗರೇಷನ್ ಡಿಸೈಡ್ ಮಾಡೋದು ಕಠಿಣ ಅನಿಸುತ್ತೆ. ಯಾವಾಗ ಮಾಲಿಕ್ಯೂಲ್ ವೆಜ್ ಡ್ಯಾಶ್ ಹಾಗೂ ನ್ಯೂಮ್ಯಾನ್ ಪ್ರೊಜೆಕ್ಷನ್ನಲ್ಲಿ ಕೊಟ್ಟಿರುತ್ತಾರೋ ಆವಾಗ RS ಕನ್ಫಿಗರೇಷನ್ ಡಿಸೈಡ್ ಮಾಡೋದು ಕೇವಲ ಕಠಿಣ ಅಷ್ಟೇ ಅಲ್ಲ, ಅಸಾಧ್ಯವೇನೋ ಅನ್ನಿಸಿಬಿಡುತ್ತೆ. ನಾನು ಈ ವಿಡಿಯೋನಲ್ಲಿ RS ಕನ್ಫಿಗರೇಷನ್ನನ್ನು ಯಾವುದೇ ಮಾಲಿಕ್ಯೂಲ್ಗೂ ಹೇಗೆ ಡಿಸೈಡ್ ಮಾಡಬೇಕು ಎಂಬುದರ ಬಗ್ಗೆ ಸವಿಸ್ತರವಾದ ಮಾಹಿತಿಯನ್ನು ಈ ವಿಡಿಯೋನಲ್ಲಿ ನಾನು ಕೊಡುತ್ತೇನೆ. ಅಷ್ಟೇ ಅಲ್ಲ, ಮಾಲಿಕ್ಯೂಲ್ಗೆ ಯಾವಾಗ ರೊಟೇಟ್ ಮಾಡಬೇಕು, ಯಾವಾಗ ಗ್ರೂಪ್ಸ್ಗಳನ್ನು ಫ್ಲಿಪ್ ಮಾಡಬೇಕು, ಯಾವಾಗ ಗ್ರೂಪ್ಸ್ಗಳನ್ನು ಸ್ವ್ಯಾಪ್ ಮಾಡಬೇಕು, ಇದರ ಬಗ್ಗೆಯೂ ನಾನು ಸವಿಸ್ತರವಾದ ಮಾಹಿತಿಯನ್ನು ಈ ವಿಡಿಯೋನಲ್ಲೇ ನಿಮಗೆ ಕೊಡುತ್ತೇನೆ. You will get answer for all your questions in this video. RS configuration rule. ಮಾಲಿಕ್ಯೂಲ್ನಲ್ಲೇ ಅಟಮ್ಸ್ಗಳಿಗೆ ಯಾವ ರೀತಿಯಾಗಿ ಪ್ರಯಾರಿಟಿ ನಂಬರನ್ನು ಕೊಡಬೇಕು ಅನ್ನೋದನ್ನು ಚಾಂಗ್-ಇಂಗೋಲ್ಡ್-ಪ್ರಿಲಾಗ್ ರೂಲ್ ನಮಗೆ ತಿಳಿಸಿಕೊಡುತ್ತೆ. ಅಕಾರ್ಡಿಂಗ್ ಟು ದಿಸ್ ಚಾಂಗ್-ಇಂಗೋಲ್ಡ್-ಪ್ರಿಲಾಗ್ CIP ರೂಲ್, ಹೈಯರ್ ದ ಅಟಮಿಕ್ ನಂಬರ್ ಹ್ಯಾಸ್ ಹೈಯರ್ ಪ್ರಯಾರಿಟಿ. ಯಾವ ಅಟಮ್ಸ್ನ ಅಟಮಿಕ್ ನಂಬರ್ ಜಾಸ್ತಿ ಇದೆಯೋ ಅದಕ್ಕೆ ಹೆಚ್ಚಿನ ಪ್ರಾಧಾನ್ಯವನ್ನು ಕೊಡಬೇಕು ಅಂತ ಈ ರೂಲ್ ನಮಗೆ ತಿಳಿಸಿಕೊಡುತ್ತೆ. ಪ್ರಯಾರಿಟಿ ಆರ್ಡರ್ ಈ ರೀತಿಯಾಗಿದೆ. ಐಡಿನ್ ಹ್ಯಾಸ್ ಹೈಯರ್ ಪ್ರಯಾರಿಟಿ ದ್ಯಾನ್ ಬ್ರೋಮಿನ್, ಕ್ಲೋರಿನ್, ಸಲ್ಫರ್ ಆ್ಯಂಡ್ ಹೈಡ್ರೋಜನ್ಗೆ ಎಲ್ಲಕ್ಕಿಂತ ಕಡಿಮೆ ಪ್ರಯಾರಿಟಿ ಇದೆ. ಸೆಕೆಂಡ್ ರೂಲ್, ಒಂದು ವೇಳೆ ಮಾಲಿಕ್ಯೂಲ್ನಲ್ಲೇ ಐಸೋಟೋಪ್ಸ್ಗಳು ಇದ್ದರೆ ನಾವು ಪ್ರಯಾರಿಟಿಯನ್ನು ಅದರ ಅಟಮಿಕ್ ವೇಟ್ಸ್ನಿಂದ ಡಿಸೈಡ್ ಮಾಡಬಹುದು. ಹೈಯರ್ ದ ಅಟಮಿಕ್ ವೇಟ್, ಹೈಯರ್ ಇಸ್ ದ ಪ್ರಯಾರಿಟಿ. ಎಕ್ಸಾಂಪಲ್ ತೆಗೆದುಕೊಳ್ಳೋಣ. ಹೈಡ್ರೋಜನ್ಗೆ 3 ಐಸೋಟೋಪ್ಸ್ಗಳಿವೆ, H13, H12, H11. ದಟ್ ಈಸ್ ಟ್ರೈಟಿಯಮ್, ಡ್ಯೂಟೇರಿಯಮ್, ಹೈಡ್ರೋಜನ್. ಟ್ರೈಟಿಯಮ್ ಅಟಮಿಕ್ ವೇಟ್ 3 ಇದೆ, ಡ್ಯೂಟೇರಿಯಮ್ದು ಅಟಮಿಕ್ ವೇಟ್ 2 ಇದೆ ಆ್ಯಂಡ್ ಹೈಡ್ರೋಜನ್ ಅಟಮಿಕ್ ವೇಟ್ 1 ಇದೆ. ಆದ್ದರಿಂದ ಟ್ರೈಟಿಯಮ್ಗೆ ಹೆಚ್ಚಿನ ಪ್ರಯಾರಿಟಿ ಕೊಡಬೇಕು ಡ್ಯೂಟೇರಿಯಮ್ಗಿಂತ. ಡ್ಯೂಟೇರಿಯಮ್ ಪ್ರಯಾರಿಟಿ ಹೈಡ್ರೋಜನ್ಗಿಂತ ಹೆಚ್ಚಿಗೆ ಇದೆ. ರೂಲ್ ನಂಬರ್ 3, ಒಂದು ವೇಳೆ ಗ್ರೂಪ್ನಲ್ಲಿ ಮಲ್ಟಿಪಲ್ ಬಾಂಡ್ಸ್ ಇದ್ದರೆ, ಡಬಲ್ ಬಾಂಡ್ ಇದ್ದರೆ ಆ ಎಟಮನ್ನು ನಾವು 2 ಸಲ ತೆಗೆದುಕೊಳ್ಳಬೇಕು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಆಲ್ಡಿಹೈಡ್ ಗ್ರೂಪ್ನಲ್ಲಿ ಕಾರ್ಬನ್ ಡಬಲ್ ಬಾಂಡ್ ಆಕ್ಸಿಜನ್ ಇದೆ, ಆದ್ದರಿಂದ ಆಕ್ಸಿಜನ್ನನ್ನು 2 ಸಲ ನಾವು ತೆಗೆದುಕೊಳ್ಳಬೇಕು. ಸೈನೈಡ್ನಲ್ಲಿ ಕಾರ್ಬನ್ ಹಾಗೂ ನೈಟ್ರೋಜನ್ ನಡುವೆ ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಇದೆ, ಆದ್ದರಿಂದ ನೈಟ್ರೋಜನ್ ಆಟಮನ್ನು ನಾವು 3 ಬಾರಿ ತೆಗೆದುಕೊಳ್ಳಬೇಕು. ಈಗ ಒಂದು ಉದಾಹರಣೆಯನ್ನು ತೆಗೆದುಕೊಳ್ಳೋಣ. ಈ ಮಾಲಿಕ್ಯೂಲ್ನಲ್ಲಿ ಪ್ರಯಾರಿಟಿ ನಂಬರನ್ನು ನಾವು ಕೊಡೋಣ. ಇಲ್ಲಿ ಕೈರಲ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಡೈರೆಕ್ಟಾಗಿ ಹೈಡ್ರೋಜನ್ಗೆ, ಕಾರ್ಬನ್ಗೆ, ಐಡಿನ್ಗೆ ಹಾಗೂ ಬ್ರೋಮಿನ್ಗೆ ಅಟ್ಯಾಚ್ ಆಗಿದೆ. ನಮಗೆ ಗೊತ್ತಿದೆ ಅಟಮಿಕ್ ನಂಬರ್ ಆಫ್ ಐಡಿನ್ ಬ್ರೋಮಿನ್ ಕಾರ್ಬನ್ಗಿಂತ ಹೆಚ್ಚಾಗಿರುವುದರಿಂದ, ಅಟಮಿಕ್ ನಂಬರ್ ಹೆಚ್ಚಿರುವುದರಿಂದ ಇದಕ್ಕೆ ಪ್ರಯಾರಿಟಿ ನಂಬರ್ 1 ಕೊಡೋಣ. ನಂತರ ಅಟಮಿಕ್ ನಂಬರ್ ಆಫ್ ಬ್ರೋಮಿನ್ ಕಾರ್ಬನ್ಗಿಂತ ಹೆಚ್ಚಾಗಿರುವುದರಿಂದ ಇದಕ್ಕೆ ಪ್ರಯಾರಿಟಿ ನಂಬರ್ 2 ಕೊಡೋಣ. ನಂತರ ಕಾರ್ಬನ್ ಪ್ರಯಾರಿಟಿ ನಂಬರ್ 3. ಎಲ್ಲಕ್ಕಿಂತ ಕಡಿಮೆ ಪ್ರಯಾರಿಟಿ ಹೈಡ್ರೋಜನ್ಗೆ ಬರುವುದರಿಂದ ಪ್ರಯಾರಿಟಿ ನಂಬರ್ ಅದಕ್ಕೆ ನಾವು ಕೊಡುವುದಿಲ್ಲ. ಎಲ್ಲಕ್ಕಿಂತ ಕಡಿಮೆ ಬರುವ ಆಟಮ್ಗೆ ನಾವು ಪ್ರಯಾರಿಟಿ ನಂಬರ್ ಕೊಡುವುದಿಲ್ಲ. ಈಗ ನೋಡೋಣ ರೊಟೇಷನ್ ಯಾವ ದಿಶೆಯಲ್ಲಿ ಹೋಗುತ್ತೆ. ನಾವು 1ರಿಂದ 3 ನಂಬರ್ವರೆಗೆ ನಾವು ಹೋಗಬೇಕು. ಈಗ 1 ನಂಬರ್ಗೆ ಐಡೀನ್ ಇದೆ, ಐಡೀನ್ ಆನಂತರ ಬ್ರೋಮೀನ್, ಆನಂತರ 3 ನಂಬರ್ ಅಂದರೆ ಕಾರ್ಬನ್. ಇಲ್ಲಿ ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ನಲ್ಲಿ ರೊಟೇಷನ್ ಕಂಡು ಬರುತ್ತೆ. ಹಾಗಾದರೆ ಇದರ ಕನ್ಫಿಗರೇಷನ್ ಏನು, ಹೇಗೆ ಡಿಸೈಡ್ ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನು ಈಗ ನಾನು ನಿಮಗೆ 4 ಕೋಡ್ಸ್ನಿಂದ ತಿಳಿಸಿಕೊಡುತ್ತೇನೆ. ನಾವು ಈ 4 ಕೋಡ್ಸ್ಗಳನ್ನು ಬೈ ಹಾರ್ಟ್ ಮಾಡಬೇಕು. ಮೊದಲನೇ ಕೋಡು HAR, ಎರಡನೇ ಕೋಡು HCS, ಮೂರನೇದು VCR, ನಾಲ್ಕನೇದು VAS. HAR ಅಂದರೆ ಏನು? H ಅಂದರೆ ಹಾರಿಜಾಂಟಲ್, A ಅಂದರೆ ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್. ಹಾರಿಜಾಂಟಲ್ ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ R configuration, horizontal clockwise ಇದ್ರೆ S configuration HCS, vertical clockwise ಇದ್ರೆ R configuration VCR, vertical anti clockwise ಇದ್ರೆ S configuration VAS. ನಾವು ನೆನಪಿಟ್ಕೋಬೇಕು. ಈಗ ಲೋಯೆಸ್ಟ್ ಪ್ರಯಾರಿಟಿ ಹಾರಿಜಾಂಟಲ್ ಲೈನ್ ಮೇಲಿದೆಯೋ ವರ್ಟಿಕಲ್ ಲೈನ್ ಮೇಲಿದೆ ಅದನ್ನು ನಾವು ಮೊದಲು ಡಿಸೈಡ್ ಮಾಡಬೇಕು. ಈಗ ಲೋಯೆಸ್ಟ್ ಪ್ರಯಾರಿಟಿ ಹೈಡ್ರೋಜನ್ ಹಾರಿಜಾಂಟಲ್ ಲೈನ್ ಮೇಲಿದೆ, ಆದ್ದರಿಂದ ಇದು ಹಾರಿಜಾಂಟಲ್ ಹಾಗೂ ರೊಟೇಷನ್ ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ನಲ್ಲಿ ಹೋಗೋದ್ರಿಂದ ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ಅಂದರೆ HAR, ಹಾರಿಜಾಂಟಲ್ ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ R ಕನ್ಫಿಗರೇಷನ್. ಆದ್ದರಿಂದ ಈ ಮಾಲಿಕ್ಯೂಲ್ನ ಕನ್ಫಿಗರೇಷನ್ R ಕನ್ಫಿಗರೇಷನ್. ನಾವು ಈಗ ಈ 4 ಕೋಡ್ಗಳನ್ನು ಯೂಸ್ ಮಾಡಿ ಯಾವುದೇ ಮಾಲಿಕ್ಯೂಲ್ಗೂ ಯಾವ ರೀತಿಯಾಗಿ RS ಕನ್ಫಿಗರೇಷನನ್ನು ಡಿಸೈಡ್ ಮಾಡ್ಬೋದು ಅನ್ನೋದನ್ನು ಈಗ ನೋಡೋಣ ಎಕ್ಸಾಂಪಲ್ಸ್ ತೆಗೆದುಕೊಂಡು. ಫ್ರೆಂಡ್ಸ್, ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಯು ಒನ್ಸ್ ಅಗೇನ್ 4 ಕೋಡ್ಸ್. ಇನ್ ದ ಮಾಲಿಕ್ಯೂಲ್ ದಿಸ್ ಈಸ್ ಹಾರಿಜಾಂಟಲ್ ಲೈನ್ ಆ್ಯಂಡ್ ದಿಸ್ ಈಸ್ ವರ್ಟಿಕಲ್ ಲೈನ್. If the lowest priority group present on the horizontal line and the rotation is in anti-clockwise direction, then it has R configuration. HAR, horizontal anti-clockwise R configuration. If the lowest priority group is present on the horizontal line but the rotation is in clockwise direction, horizontal clockwise S configuration. When the lowest priority group is present on the vertical line and if the rotation is in clockwise direction, then it has R configuration, vertical clockwise R configuration VCR. If the lowest priority group is present on the vertical line but rotation is taking place in anti-clockwise direction, then it has vertical anti-clockwise S configuration. Now let us solve few examples. In this molecule, we have to find the RS configuration of the chiral carbon atom. Here, this chiral carbon atom has attached directly to oxygen, carbon, nitrogen and carbon. Oxygen gets higher priority as it has higher atomic number, so it has priority number 1. Then comes nitrogen. Now, this chiral carbon has attached to carbon. Here is also carbon. Now we have to compare the second atom. Second atom, here it is hydrogen. If you see the second atom, here is another carbon. Therefore, this has higher priority, so it gets priority number 3. Now we have to go from 1 to 3. So the rotation take place in this direction. So the rotation is in anti-clockwise direction. Where is the lowest priority group? Lowest priority group, it is on the vertical line. Vertical line mele lowest priority group ide. Rotation anti-clockwise, vertical line anti-clockwise S configuration. Therefore, E molecule nalli chiral carbon atom configuration ide S configuration. Now let us consider this molecule. This chiral carbon attached to hydrogen, chlorine, deuterium, tritium. Chlorine has more atomic number, so it gets first priority, then tritium, then deuterium. So the rotation is from 1 to 3 is in clockwise direction and lowest priority group is on vertical line. Vertical clockwise R, VCR. Therefore, this chiral carbon atom has R configuration. This chiral carbon atom this chiral carbon atom has R configuration. This molecule has R configuration. Now let us consider one more example. Here the chiral carbon atom is directly attached to here carboxylic group, here aldehyde group, here carbon, here also carbon. Now we know already when there are double bonds, we have to take those many times of atoms. So in carboxylic group, there is a double bond between oxygen and carbon. So oxygen has taken 2 times and OH. And in aldehyde group also, the carbon is having double bond with oxygen. So oxygen has taken 2 times and hydrogen. ಈಗ ನಾವು ಪ್ರಯಾರಿಟಿ ಕೊಡೋಣ. ಈ COOH ಗ್ರೂಪ್ನಲ್ಲಿ ಹೆಚ್ಚಿನ ಆಕ್ಸಿಜನ್ ಐಟಮ್ ಇರೋದ್ರಿಂದ ದ ಪ್ರಯಾರಿಟಿ ಫಸ್ಟ್. ಆ್ಯಂಡ್ ಆಲ್ಡಿಹೈಡ್ ಗ್ರೂಪ್ನಲ್ಲಿ 2 ಆಕ್ಸಿಜನ್ ಇದೆ, ಆದ್ದರಿಂದ ಅದು ಪ್ರಯಾರಿಟಿ ಸೆಕೆಂಡ್. ಈಗ ಈ ಕಾರ್ಬನ್ ಕಂಪೇರ್ ಮಾಡಿದ ಮೇಲೆ ಕಾರ್ಬನ್ ಸೇಮ್ ಇದೆ. ಸೆಕೆಂಡ್ ಆಟಮ್ ಕಂಪೇರ್ ಮಾಡಿದರೆ ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಇದೆ, ಇಲ್ಲೇ ಇನ್ನೊಂದು ಕಾರ್ಬನ್ ಇದೆ. ದರ್ಫೋರ್ ದಿಸ್ ಗೆಟ್ಸ್ ಮೋರ್ ಪ್ರಯಾರಿಟಿ. ನಾವು ಈಗ 1, 2, 3 ಡಿರೆಕ್ಷನ್ನಲ್ಲಿ ಹೋದರೆ ಇಟ್ ಈಸ್ ಕ್ಲಾಕ್ ವೈಸ್ ಡಿರೆಕ್ಷನ್ನಲ್ಲಿ ರೊಟೇಷನ್ ಆಗ್ತಾ ಇದೆ. ಹಾಗೂ ಲೋಯೆಸ್ಟ್ ಪ್ರಯಾರಿಟಿ ಗ್ರೂಪ್ ವರ್ಟಿಕಲ್ ಲೈನ್ ಮೇಲಿದೆ. ವರ್ಟಿಕಲ್ ಲೈನ್ ಕ್ಲಾಕ್ ವೈಸ್ ಡಿರೆಕ್ಷನ್ ಆರ್ ಕನ್ಫಿಗರೇಷನ್ VCR, ವರ್ಟಿಕಲ್ ಕ್ಲಾಕ್ ವೈಸ್ R configuration. Therefore this molecule has R configuration. ಈಗ ಮತ್ತೊಂದು ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಮಾಲಿಕ್ಯೂಲ್ ಕನ್ಸಿಡರ್ ಮಾಡೋಣ. ಈ ಮಾಲಿಕ್ಯೂಲ್ನಲ್ಲಿ 2 chiral ಕಾರ್ಬನ್ ಆಟಮ್ ಇವೆ, C2 C3. 1 2 C1 C2 C3 C4. We have to find out the R and S configuration of C2 and C3 carbon atom. How we can do? We know that CHO group has carbon double bond oxygen, so we have to write carbon 2 times oxygen and hydrogen. Now let us find the RS configuration of C2 carbon atom. This C2 carbon atom has attached to oxygen, carbon, hydrogen, carbon. So oxygen has higher priority. Then this carbon atom has 2 oxygen atoms, so this gets second. And lower group, all lower group get third priority. So 1 2 3, if we go from 1 2 3, it is anti-clockwise rotation. Lowest priority group horizontal line ಮೇಲಿದೆ, anti-clockwise. horizontal line ಮೇಲೆ lowest priority group ಇದೆ, anti-clockwise direction HAR. Therefore C2 carbon has R configuration. ಈಗ C3 ಕಾರ್ಬನ್ ಆಟಮ್ನ RS configuration ಡಿಸೈಡ್ ಮಾಡೋಣ. This chiral carbon atom attached to oxygen, so oxygen gets first priority. Then there are 2 groups. One is above group and this is below group. This above group gets more preference than below group because this carbon is attached to carbon and oxygen. This carbon is attached to hydrogen and only one oxygen. Therefore above group gets second priority and this group gets third priority. Therefore rotation take place from 1 to 3, means it is taking place in clockwise direction. And lowest priority group elide hydrogen. Lowest priority group horizontal line melide. Horizontal line rotation is in clockwise direction, HCS. Therefore third carbon atom has S configuration. Now let us take few more complicated examples. Now students, let us find the RS configuration of glucose molecule. Glucose molecule has 4 chiral carbon atom. This is second carbon atom, third carbon atom, fourth carbon atom and fifth carbon atom. We have to find RS configuration of these 4 chiral carbon atom. Let us find the RS configuration of carbon atom 2. This carbon atom is attached to oxygen, carbon, hydrogen and carbon. Therefore oxygen gets first priority, so I give first. Then this carbon is having 2 oxygen atoms, so it is having second priority. Then the lower group carbon gets third priority. The rotation take place from 1 to 3. That means the rotation is in anti-clockwise direction. The lowest priority group is present on the horizontal line and the rotation is taking place in anti-clockwise direction. We know that HAR. So the configuration of second chiral carbon atom is R. Then the RS configuration of third carbon atom. Here this carbon atom has attached to oxygen, hydrogen, carbon, and we know that oxygen has higher priority, so it gets number 1. And the above group has carbon and 2 oxygen atoms, and the lower group has carbon and single oxygen. Therefore above group get higher priority and lower group gets lesser priority. Therefore it gets priority number 3. We have to go from 1 2 3. The rotation is taking place in clockwise direction and the lowest priority group hydrogen is present on the horizontal line and the rotation is in clockwise HCS. Therefore, the carbon atom 3 has S configuration. Now let us find the configuration of third carbon atom. This chiral carbon third has attached to oxygen and carbon and above group and hydrogen, and here carbon and lower group. Now as we know, oxygen gets first priority and this above group has more oxygen here, so it gets second priority and lower group gets third priority. So we have to go from 1 2 3. Again the rotation is taking place in anti-clockwise direction. Lowest priority group is present on the horizontal line, horizontal anti-clockwise HAR. Therefore the fourth carbon atom has R configuration. Now let us find the RS configuration of fifth chiral carbon atom. This chiral carbon atom is attached directly to oxygen, carbon and hydrogen. So oxygen gets first priority and this carbon has more number of oxygen above, therefore its priority is higher than this lower group. So this gets second and this third. 1 2 3. Again the rotation is taking place in anti-clockwise direction and the lowest priority group is present on the horizontal line, anti-clockwise HAR. Therefore the fifth chiral carbon atom, has R configuration. These are the RS configuration of carbon atoms: second, third, fourth and fifth. R, S, R, R. Now we will learn how to assign the RS configuration for wedge dash projection. This is wedge and this is dash. To assign RS configuration, we have to modify this structure into Fischer projection. Before we assign RS configuration, we have to modify this wedge dash projection into Fischer projection. How we can do this? We have to draw a cross here and we have to bring wedge and dash on horizontal line. We have to bring the groups present on the wedge and dash on the horizontal line. And we have to remember that where the dash is present, we have to keep that dash group on that side only. If you see, the dash group is present on the right side, so we have to keep hydrogen atom at right side and wedge should bring the at left side. Then the atoms present on the normal line should be, this is at top and this will come at bottom. Similarly, we will convert this wedge dash projection into Fischer projection. We have to draw a vertical, we have to draw a cross line and we have to bring the wedge and dash on the horizontal line and we have to keep the dash group at the same side. Here dash group is at left side, so I write H at left side and OH at right side, and the group present on the normal line, that is at top, and this is at, we have to write at bottom. Now let us assign the RS configuration for this. First we will give the priority. We know that iodine has higher atomic number, then comes the chlorine, then comes the fluorine. So the rotation is taking place in clockwise direction, that is 1 2 3. The lowest priority group is present on the horizontal line and rotation is taking place in clockwise direction, therefore it is HCS. Therefore this chiral carbon atom has S configuration, and in this case iodine, oxygen, carbon. Iodine has higher priority, so it gets 1, then comes oxygen, then comes carbon. So rotation is taking place in 1 2 3, that is in clockwise direction. Where is the lowest priority group? That is on the horizontal line, horizontal clockwise HCS. Therefore this chiral carbon atom has S configuration, this molecule has S configuration. Now let us try to assign RS configuration for this molecule. If we see this molecule, first we have to make some adjustment. Let us rotate this molecule in anti-clockwise direction. It will appear like this. This is CHO and this is the dot, and this will go here CS3 and this will be COOH group. Now it becomes very easy that the wedge and dash are at left side. Now we have to convert this molecule into Fischer projection, and we should remember that we have to draw a cross, and we should remember that the dash group should be kept there only where it is. Dash is at left side, so hydrogen is kept at left side, and wedge comes to right side, and this will be CS3, and here this is COOH. Now here we have to assign the priority. We know that carboxylic group gets higher priority, so this becomes 1, and this becomes CHO group which gets second priority, and CS3 will third. So the rotation is taking place in 1, 2, 3 anti-clockwise direction. The lowest priority group is present on the horizontal line, anti-clockwise rotation, that means HAR. This molecule has R configuration, and this chiral carbon atom has R configuration. Now let us consider one of the more complicated molecule. We have to assign the RS configuration of this carbon as well as this carbon atom second and carbon atom third. We have to assign RS configuration. Wedge is given, dash is understood that here in order to complete the tetravalency hydrogen is present. Here also in order to complete the tetravalency this carbon atom is also having hydrogen here. Now we have to convert this wedge dash form into Fischer form. There are two carbon atoms, therefore we have to draw two horizontal lines and one vertical line. This is the CS3 group, and this is the first horizontal line we have to create, and we know that the dash is at left side, so hydrogen should be kept at left side and OH should be at right side. And this is second horizontal line we have to create. Here the hydrogen is at left side, dash is present at left side, and OH should be written at right side, and this group is at bottom. Okay, now we have to find the configuration of C2 carbon atom and C3 carbon atom. Let us find the RS configuration of this molecule. The priority order is oxygen gets first, then this lower group gets second, and this methyl group gets third priority, because you see here this chiral carbon is attached to here also carbon, here also carbon. Then the second atom we have to compare. Here second atom is hydrogen, third atom is also hydrogen. Here this carbon atom has second atom oxygen, so priority is more. So we have to go from 1 to 3. 1, 2, 3. That means the rotation is taking place in clockwise direction. And lowest priority group is present on the horizontal line, clockwise direction, HCS. Therefore this C2 carbon atom has S configuration. Now let us find this C3 carbon atoms RS configuration. This is attached to oxygen CS3, and above group oxygen gets first preference, above group gets second preference, and this group gets third preference. We have to go from 1 to 3. The rotation is taking place in anti-clockwise direction. Lowest priority group is present on the horizontal line, anti-clockwise, that means R configuration. Therefore C3 carbon atom has R configuration. Friends, now I will explain you how to assign RS configuration for Newman projection. This is eclipsed structure of Newman projection, and this is staggered structure of Newman projection. Now here we have to remember, we have to convert this Newman projection into Fischer projection. How we can do that? Here if you see, front side there is one chiral carbon atom is there, and exactly back side also there is one chiral carbon atom. Therefore we have to draw two horizontal lines like this. Above horizontal line it represents the front side carbon atom, and this horizontal line has left side hydrogen, right side OH group, and the top molecule is COOH, and back side chiral carbon atom, it should be inverted. COOH group is written here at the bottom, and left side hydrogen and right side OH group. Now let us assign the RS configuration for this chiral carbon atom. This has oxygen, oxygen has first priority, and this COH group gets second priority, and this carbon gets third priority. So we have to go from 1 to 3. So rotation is taking place in anti-clockwise direction. Lowest priority group is present on horizontal line and anti-clockwise. Therefore this is R configuration. Therefore this carbon atom is R. This carbon atom has R configuration. Now let us assign the RS configuration for this chiral carbon atom. Oxygen gets first priority, then COH group gets second priority, and this above group carbon gets third priority. We have to go from 1 to 3. So the rotation is taking place in clockwise direction. Lowest priority is present on the horizontal line and clockwise direction rotation. Therefore it is HCS. Therefore this chiral carbon atom has S configuration. Now finally we will assign RS configuration for staggered configuration. There is a slight difference we have to make while converting staggered form into Fischer projection. Here again there are two chiral carbon atoms, so we have to draw two horizontal lines and one vertical line, and the front side carbon top group is at the top, and left side hydrogen and right side OH group. Now what we have to do is, here one change we have to do, the OH group, that is it remains at the bottom of the molecule. Only thing, this COH group and H group we have to swap, we have to flip. That means COH group comes here and H atom goes there. So this is how we can convert the staggered form into Newman projection form. Once again I will repeat, the front carbon atom is written as it is, horizontal line on horizontal line H and OH, and this group at the top, but the chiral carbon at the back side in staggered conformation we have to swap it. So the groups are swapped or the groups are flipped, then we get here COH and H comes here and OH group here. Now we have to assign the RS configuration for this chiral and this chiral. Oxygen gets first priority, carboxylic group gets second priority, this lower carbon gets third priority, 1, 2, 3, that is anti-clockwise direction. The lowest priority group is present on horizontal line, anti-clockwise HAR. So this carbon has R configuration, R configuration. Now let us consider this carbon atom. Here oxygen gets first priority, carboxylic group gets second priority, this carbon and above group gets third priority. Now the rotation is taking place 1, 2, 3. That is, lowest priority group is present on horizontal line, rotation is taking place in clockwise direction, therefore HCS. Therefore this carbon atom has S configuration. In this way we can convert the Newman projection into Fischer projection, then we can assign the RS configuration. Please take the screenshot of this and you try to practice to assign RS configuration for different molecules. Students, I hope you have enjoyed this. Friends, I have taken a lot of efforts in making this video. Please like, share and subscribe my channel, and I am thankful to YouTube and millions of YouTube viewers.